sure we're ready for the test coming up here. So we're going to start right away. What is the law of sines? Just need to write the formula. Law of sines is sine of A over A equals sine of B over B equals sine of C over C. This should be a real nice and easy way for your virtual answer key to start, and hopefully a quick 2 points on your test. Nice and easy. For which triangle setups does the law of sines work? When can you make the proportion work here? Well, you're going to make it work with side-side angle. We talk about that a lot. Angle-side angle will also work, and angle-angle-side will be the third one. The ones that do not work, so for number 3, the ones that are left. Side, side, side doesn't work because I'd have all 3 sides, nothing on top. Angle, 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 same way. And side, angle, side, I would have a side, an angle, and a side. It just won't work there. So those should be 3 quick ones to start. Number 4, how do you find the second possible angle in your ambiguous case? This is going to be, again, pretty straightforward. Just try to explain it that whenever you find your first angle, so find the first angle, and then you're going to do 180 minus the angle. And that'll find your second possible angle. How do you know if a triangle does not exist in the ambiguous case? When you're finding some angle, we'll call it theta. If you get sine of theta, it's bigger than 1, then the triangle will not exist. The triangle does not exist. Last one, so triangle angle is blank or blank. If the given angle is blank or blank, we can only have one triangle formed. That is if we have a right triangle or if we have an obtuse triangle. Those are our 2 possibilities for that one. All right, now on to the fun ones of solving these problems, solving these proportions. First thing you want to look at in each one of these is what kind of triangle do we have. If it helps to draw it out, then definitely do so. Triangle A, B, and C here. A is 54, C 83, and side A 18.1. Okay, well, I can find some other angles here. Well, let me first write in what we know. You're going to have something like this on your test the same way. So write in what you know, 54 degrees, 83 degrees, and side A 18.1 degrees, or 18.1 inches, I should say. What can I then find out? Well, I can find angle B immediately. It's 43 degrees. 43 degrees because 54 plus 83 plus 43 gives me my 180. That means angle B is 43 degrees. Now, to find sides B and C. Well, I already have one set, A and A, that work well. So I'm going to do sine of 54 over 18.1 is going to equal sine of 43 over side B. Cross multiply, B sine of 54 equals 18.1 sine of 43. Divide by sine of 54, and I should get B equals 15.3. And same thing for side C. I'm going to do sine of 54 over 18.1 is going to equal, now we want side C, so I'm going to do sine of 83 degrees over side C. Cross multiply and divide again, C equals 22.2. Just like that. All right, moving forward to number 8. Number 8, you should notice here, again, with or without drawing a triangle, that you are going to have side-side angle in this case. Write in what you know, 58, 4.5, 12.8. And we need to see what we can find out. Well, I have both parts of A, so I'm going to set that up immediately. Sine of 58 over 4.5 is going to equal sine of big B over little b, which is 12.8. Cross multiply, 4.5 sine of B equals 12.8 times sine of 58. Divide, and I should get sine of B is going to equal here in this case, sine of B will equal 2.41. Well, I should know immediately now this triangle does not exist. If you try to take the inverse sine of both sides, you're going to get an error message. So the triangle does not exist. That's all you need to write, that it does not exist. Number 9, another side-side angle problem coming up here. In this one, same thing, what do we know? We know 60 degrees here, 10, and 9. In this case, I have the b's already. Sine 60 over 9. I'm going to need to find angle A first because I know side A of 10. So sine of big A over 10. When I Due to cross multiplying and then divide, I should get sine of A equals 0.9623, something like that. I'm going to take the sine inverse. I definitely can get a triangle this time. And when I do that, I'm going to get here that A is going to equal 74.2 degrees. I can either wait till later to find the second angle, if there is one. Remember, we got 74.2. Remember, this is side angle. We need to ask, are there two triangles? So we can check now or later. I'm going to check right now just to see. The other possible triangle would be, or the other possible angle here would be 180 minus 74.2 degrees. That angle would be 105.8 degrees. And yes, that would be a legal triangle here because 105.8 plus the 60 that was in our original triangle up here, they add up to be 165.8. That's definitely a legal triangle. So let's find out. This would be what our B prime would be. So go back here, or I'm sorry, that would have been not B prime, that would have been A prime. So let's go back. If we knew angle A was 74 degrees, knowing angle B as well, we can then find what angle C is. Angle C is going to be 74 plus 160, and then subtract that from 180. So I should get angle C here is 45.8 degrees. 45.8. And then find the last side in that first triangle. I would do sine of 60 over 9 will equal sine of 45.8 over side C. Cross multiply and divide, I should get C equals 7.45, or when we want to the 10th, so we'll say 7.5. So that's our first triangle all there in blue. What I'm doing in green is the second triangle. We said the second angle A prime equaled 105.8, 105.8 degrees. When that's the case, we would find C prime would be 180 minus 165.8, which should be 14.2 degrees. So that's our other possibility here. And then side C, I'll set up very similar to this one over here. I'm going to say sine of 45.8 degrees over, or I'm sorry, not 45.8. I should have sine of 60 over 9 is going to equal sine of 14.2 over my new side C. And when I cross multiply and divide here, I should get C equals 2.5. So on your test, when you have two possible answers, you need to be able to write A is one or the other. C is one or the other. Side C is one or the other. Have both ones written down somehow. If you want to make a second set, a second set of this big list here, then by all means go ahead and do it. If you want to rewrite it out here, angle A in second triangle, if you want to do something like that, go for it. Whatever you need to do, just let me see for sure that there are two possible answers. Okay, number 10. You should notice right away, especially in the picture, that we have side, angle, side here. Now, if you wanted to try to figure out, based on how this is setting up, we could look, okay, angle D is 41 degrees, side T, 20, side O, 36. Looking at this, I already do not have any proportions that I can set up at all. So all you have to say is this triangle, well, not that it doesn't exist. I shouldn't say that. I should just say we cannot solve this. We don't have enough information yet. Again, law of cosines later. You see side angle side, think, no, Dotson, can't do that. Number 11, another side angle. But this one you should know immediately that there's only one possible answer, and that's because of our angle 110 degrees here. So what we are given in this one, angle I 110, side N 16, can't read my own writing, and side I is 48. Only one possible answer because it's an obtuse triangle. Sine of 110 over 48, we need to find angle N first, sine of big N over 16. Sine of N is going to equal 16 sine 110 over 48, which is going to equal here, should be 0.314. 3, which means when we take the inverse sine, we're going to get angle n is equal to 18.3 degrees. So we found here 18.3 degrees. When I subtract, I find angle S that same way, 51.7 degrees. That leaves me with one more step to find side S. So sine of 51.7 degrees over S equals sine of 110 over 48, which means when I cross multiply and divide, S should equal 40.1, and that's your answer, 40.1. Number 12, triangle UHS. In this one, we should see angle, side, angle for our problem. We are given the following information. We're given that U is 125. We're given that H equals 20 degrees, and we're given that side S is 60. Now don't be confused. It doesn't look like we have a proportion. However, we can find angle S immediately to be 35 degrees because all three need to add up to 180. Now I do have a valid proportion. Now I can say sine of 35 over 60 is equal to sine of 20 over H. Similarly, I can say that sine of 125 over U will equal sine of 35 over 60, the exact same way. Cross multiply and divide, when I do that, I should get H is equal to 35.8. Over here, to get U, I should get 85.7. 85.7 for U, 35.8 for side H. So that's it for those, and that leaves just those lovely application problems. Starting with number 13, you can read up on World War II history if you would like, but what we need to do is figure out what this picture looks like. Draw a triangle. So Squadron A, Squadron B, and here's point C where they look out. 68 degrees here, 42 here, and this distance over here should have been your 425. Kind of like the last problem we just did, we need to find what this third angle, angle B, is. They should add up and give you that angle B is equal to 70 degrees. So that's a good place to start. And from there, now we have both parts of B, so that's what I need to use. Sine of 70 degrees over 425 feet equals, now let's not forget what we need to look for. We need to know how long of a bridge they need to build. How far is it from A to B? So this is what I need here is essentially side C. Is what I need to find. So sine of 70 over 425, I want to use C, so I will use sine of 42 degrees over side C. C sine 70 equals 425 sine of 42. That means that C is going to equal 302.6 feet. That's how long the bridge will be. That's your final answer. All right, number 14 is a little bit trickier, but really it's not too bad at all. We're going to look at triangle PIT. So we're going to label PIT. What we know is that side P is 95, side P is 54, and the angle in the middle, 62.5 degrees. Now, what we want to look for here is to try to get area. Remember, area of a triangle equals 1/2 the base times the height. Well, we know a couple bases that we can use. What we would need to figure out is the height. So it doesn't matter which base you want, 54 or 95. I'm going to do it this way, for 54, and make a right triangle here. Now I see I have a right triangle that I'm going to try to highlight here right now in, well, Pittsburgh yellow, just so you can see what we're looking at. If I were to kind of rotate it so you can see maybe a little easier, I would have right here, this would be my I, this would be my T. The angle is at 62.5. The hypotenuse is 95. I need to find that height. Well, that's not too difficult to do. We've done that a few times now. I can do that with my old right triangle trick. And say that sine of 62.5 degrees is going to equal the opposite, which is h, over the hypotenuse, 95. So my height is 95 times sine of 62.5. So my height is 84.3 degrees, or not degrees, 84.3 is my height. So if I'm using the area formula, 1/2 base times height, I need to use this as my base because I chose this as my height. So area should equal 1/2 times 54 times 84.3. which will give me as my answer of 2,275 meters squared, since we were dealing in meters. All right, the last one, the toughest one, helicopter searching for fugitives. This is number 14 again, so I guess we'll now call it 15, just because I can. Picture that we're looking at, we'll look at part A here, part B over here. In part A, they want to be on opposite sides. So there's my helicopter. Here's guy A, fugitive B. Draw your triangle. We're going to want to eventually see what the height is, like that. So, again, name the triangle if it helps, which I definitely would suggest. AB, helicopter C. What we know for a fact is the angles are 23 and 31. Doesn't matter which one goes where. And they are 1,000 feet apart. So when I do that, I should then be able to say immediately, okay, this big angle C, this whole thing, is going to measure 126 degrees. Angle C is 126 degrees. From there, it doesn't matter which way I go. I can, if I use side A or side B. So I'm going to say side A here, just because I can, and show you that sine of 126 over 1,000, so that's for the C part, because I know both, is going to equal sine of 23 degrees over A. Cross multiply and divide, I should get A equals 482.97. If I were to do it with side B, I would have gotten that B was equal to 636.6. Doesn't matter much. In the end, what you need to do then is now I have a right triangle I can look at. I found part A. I'm looking now at this right triangle. I have an angle. I have now this side A. I need to find height. This is another sine, kind of like we did in the first 14. Sine of 31 degrees is equal to A over H. A is 482.97. Or I said that backwards. It should be H over A, opposite over hypotenuse. So it should be H over 482.97. Multiply both sides by that 482, and I'll get the height is 248.6 feet. And that'll be the same if I use side A or side B. Now, for part B, the picture is going to look something like this. They are both on the same side of the helicopter. The guys are still 1,000 feet apart. We're going to name it again as triangle A. Well, I'm going to try to name it as triangle A, B, C. When I do it this time, now remember, the angles, the bigger angle has to be closer to my 90-degree angle. Bigger angle must be closer. So 23 is here, 31 is here. 31 and this guy make a linear pair. That means this angle on the inside must be 149, which means my top angle, angle C, is going to be 8 degrees, because 8 plus 149 plus 23 add up to 180. So, again, same sort of thought process going through here. We're going to say now that sine of 8 degrees over 1,000, because we know both parts of part C, is going to equal, let's say I want to find side A. I could do side B if I wanted to. Doesn't matter, but I'm going to do side A. I'm going to say it equals sine 23 degrees over side A. That means A is going to equal here 2,807.5, 2807.5. Again, if I wanted to do B, I would have gotten B equals 3,700.7. Since I found A, this is the right triangle I'm looking at. I'm going to redraw it so you can see it. This right triangle is 31 here. I know A is 2807.5, and I want to find the height. So sine of 31 degrees equals my height over 2807.5, which means my height equals, when I multiply by 2807.5, my height is 1,445.9 feet. So answer to part A, down there in green, 248.6 feet. Answer for part B in orange, 1445.9 feet. And there we have it. Hopefully we'll be in perfect shape here for this test coming up. And all I can wish you is nothing but good luck.